So that was rate of change, and now we're going to go on. This is the exact, I think, yeah, this is the exact same page, but now we're looking at the initial value. And the initial value is the value at, whoops, I can't spell the word at apparently. The value at the beginning. I don't know how to spell beginning here. So it's the value at the beginning. It's the value at time 0. Usually. This is usually. Okay. So when the time is 0, what is the value? Or what is the value at the beginning? That's what we're going to be looking at. And it's actually very, very easy to do. So here's time 0, right? Here's time 0. Looking on the graph, this is time 0. This right here is time 0. And so what is the initial value? So the initial value here, that's what we're looking for. What is that initial value? Well, it's right here. At time 0, the initial value is 12. At time 0, the initial value is $15. At time 0, the initial value is around 15. At time 0, the initial value is, I guess, also around 15. Those look like the same graphs. Maybe I can make a different one for later. Here, and this one's not so obvious, but at time 0, like we have done no time, what is the initial value? Well, the initial value, they charge $500 just initially. And then there's something per hour. Or here, there's this truck driver and they charge $50 initially. So those are all of our initial values. So that's what I'm going to write down. So our initial value. Now we, for whatever reason, say B. B is our initial value. So our B value here, our initial value is 12. For this one, our B value, our initial value is 15. Going on here, this thing, the B value for this graph, the initial value is 15. This one, which I'll probably have to change, the B value is 15. Here, the initial value, our B value, we initially get charged $500. And for this one, we initially got charged 50. So that's our initial value. So I'm actually going to use this to move on to the next page because that part's pretty quickly. And that part was pretty quick. So the next page is the equation of a graph. And it's always your initial value. So y equals your initial value, which we call b, and then the rate of change, the rate of change. So b plus the rate of change. Now the rate of change is m. For whatever reason, mathematicians have just used m. And then they have here, I'm going to change this. Actually, I'll change this right now. Okay, I changed the order here a little bit, changed it right now. Whoops, I typed something in there, need to change that. But y equals the rate of change, and for that, the rate of change, rise over run, we call the letter m, and the initial value, which I'll have to delete that extra 2 letters there, that's our b. So y equals the rate of change, or m, times our x, plus our b. And so that y equals mx plus b, we do a lot of that in grade 10, graphing these lines. So we take a look at the exact same page. If you go back to the other pages, you'll realize that our m value, which was our slope, that was 3, and our b value was 12. So when we create our equation, we'll say mx, so m is, well, I'll write this, y equals mx plus b. So when we write this, well, our m is 3x and our b is 12. And that is an equation of a line. And like I said before, we'll graph that later, but it's good to come up with that equation. Now this one, the second one here, our m was our slope, and that was 20 over 2, if you can remember, which was 10. Our b value, this was 15. So when we have our equation, y equals mx plus b, they want us to put in the m, so 10x, and then plus our b value, which in this case is 15. So that's what we're doing for all of these. We're taking our m, we're taking our b, and we're putting them together to create an equation. So this one, oh look, that's what the graph should have looked like. So I don't know why it didn't look like that. Maybe I'll change it for the one above here after. But our m value for this, you can go back and take a look. In fact, I need to go back and take a look, so I'm going to zoom out here and scroll up. Our b was 15, but what was our m? Our m was 5. And then for the service for Christopher's computer, our slope or our m was 30. But for this one, it's 5. So let's go down here. So our slope was 5, and our initial value, that was our initial height, was 15. So again, you can look back at those if you want those numbers, but when we this page, we're just trying to create the equation. So mx, so 5x plus 15. And then I'll do the other one after, but let's do this. Our m value was our rate of change. Well, that was the 250. Our initial value was 500. So the equation of the line, y equals mx plus b, is going to be y equals 250x plus 500. And Terrence, the truck driver, so our m was 0.10. That was our rate of change. Our initial value was 50 bucks. So our equation, y equals mx plus b, is going to be 0.10x plus 50. And I will now just pause this and edit that this service for Christopher's computer. All right, so I did copy it. So I'll go back to that second page, which yours will actually match. And I will do the initial value. So the initial value is the initial height. So when the time is 0, what is the initial height? So we call that B. In this case, for Christopher's computers, the initial value is 50. And if I scroll up to here to the first page, was already Christopher's, we had calculated the slope to be 30. So the slope was 30, the initial value was 50. So our slope for this thing, our m, was 30, and our initial value was 50. So when we write the equation of the line, y equals mx plus b, we would do y equals 30x plus 50. And so that's our equation based off of our initial value and based off of our rate of change. So this was, these 3 pages worked towards building your final equation of a line, which we won't get into in this unit in graphing these things, but we will later. And so we looked at getting the equation from the table of values. We looked at getting them from graphs, and we looked at them from getting them from descriptions. And now we're going to put all this together with lines of best fit and with data and answering questions in the last, I think there's one more example.